Okay, chapter 3. Day 5 video. Okay. Chapter 3, day 5 video. What we're going to focus on is how do we solve radical equations. So now we've simplified them. We've added, subtracted, multiplied, divided, rationalized denominators. But now what if there's an equation? These equations look many different ways. Sometimes you'll see very oddball looking ones, sometimes it's more normal looking ones, sometimes you're in word problems, but somewhere in the problem you'll see a radical and you'll see an equal sign. And you know that if you have a radical with a variable in it and an equal sign, you know we have radical equations. So the first thing we have to do to solve radical equations is we want to isolate the radical on one side. Isolate, get it all by itself. So right now I have a 3 over pi near it. I need to get that away from it. And I use opposite operations to do that. So just like when we solved absolute value equations, we want to get this all by itself. So I'm just going to multiply both sides times pi over 3, because that one is what will cancel that out. So I'm going to multiply pi over 3. So this is just undoing operations. I'm initially multiplying, so I'm going to divide. I'm initially dividing, I'm going to multiply. Whatever I do over here, I have to do over here. So I have the square root of 14x equals 10 pi over 3. All right. Once I have this radical isolated, then I can square both sides. Squaring is the opposite of square rooting. It's the undoing of square rooting. All right? So what I'm going to do is just put this, whatever this radical is, in parentheses, and then I write squared out there. Squared. Okay? Squaring both sides will undo the radical. Now, we talked earlier about the fact that the square root of anything squared is going to be just the anything, because you're doing and undoing the operation. So this just turns into 14x on that side. It's really nice, no matter what this is, if it's under the square root and you square it, whatever this is just comes down right here. So this, you just rewrite without the square root symbol once you've squared it. This I have to square. So 10 squared is 100. Pi squared is pi squared over 9. Now, solve what is left for the variable. All right, solve what is left for the variable. So, let's see. I got to get rid of the 14 next to the x. So I'm just going to divide both sides by 14. Divide both sides by 14, which is the same as multiplying by 1 over 14. So, x equals, well, I need to do a little bit of math here. I know that 2 can go in here 7 times, and 2 can go in here 50 times. So it looks like I have 50 pi squared over 9 times 7, 63. Just using some of the rules around multiplying with fractions. Solve what is left for the variable. Okay, my answer is 50 pi squared over 63. Now, the last thing though is to check, make sure this is going to work, and reject any non-working answer. We don't reject negative answers just because they're negative. We don't reject positive answers that look funny just because they look funny. We have to check to make sure that the answer really truly does work. And if it does, then we'll circle it. And if not, we'll reject it. So down here, I have my check. And to check, I have to go back to the original problem, which was 3 over pi, radical 14x equals 10. So 3 over pi, radical 14, I'm going to take this and put it right in for x, equals 10. And I'm just going to work on this side and see if I can get this side equal to 10. All right, so 14 times 50 is 700. So I get 700 pi squared over 63. Now just do a little cleanup here. I know that 9 or 7 can go into 700 100 times, and 7 can go into 63 9 times. And now I have the square root of 100 over the square root of 9, the square root of pi squared. Well, the square root of 100 is 10. 9 is 3. Square root of 9 is 3. And the square root of pi squared is just pi. And so this is 3 over pi. 3 over pi times that. That works out nice because the 3's will reduce, the pi's will reduce, leaving me just 10. And so what I have left is 10 equals 10. And that checks. So my answer's good. I circle it. That's a good answer. Let's take a look at a more traditional looking problem. Solve for x. We have square root of 2x minus 3 plus 2 equals 7. Notice the plus 2 is not under the radical. So step 1, isolate. Get this radical all by itself. So I'm going to take away 2, take away 2. The square root of 2x minus 3 equals 7. Take away 2 is 5. Step 2, square both sides. Okay? The square root of anything squared is the anything. 5 squared is 25. Solve what is left for x. So add 3, 2x equals 28. Divide by 2 and x equals 14. Now I have to check. So the square root of 2 times 14 minus 3, all under the square root, plus 2 equals 7. I need to get this side to say 7. So the square root of 14 times 2 is 28, minus 3 is 25. Square root of 25 is 5. And 5 plus 2 is 7. Checks. So my answer's good. Circle it. So isolate, square both sides, solve what's left for x, make sure it works. If it doesn't work, we would write reject. Let's try one more here. All right, so I'm going to add radical 5 minus x to both sides, just because I like it being negative, I guess. So x equals 3 plus radical 5 minus x. Move the 3 over to this side, take away 3, and I get x minus 3 equals the square root of 5 minus x. There, we're isolated. Square both sides. Okay, if you remember, when we square a binomial, we can't just multiply first and last. That only works if it's a conjugate of each other, and which is not squaring a binomial. Squaring a binomial means write this out twice. X minus 3 times x minus 3. The square root of anything squared is the anything. Okay, so x minus 3 times x minus 3. Well, if I do FOIL, right? First outer, so I get x squared minus 3x. Inner, minus another 3x. Last, plus 9 is equal to 5 minus x. So I've isolated, I've squared both sides. Now what I have left, I have to solve for x. And I notice it's now an x squared problem, which means we got to get it all to one side and get it equal to 0 and do some factoring. Let's clean this up a little bit though. X squared minus 6x plus 9 is 5 minus x. Bring this over. So take away 5 and add x. Take away 5 and add x. All right, so I have x squared minus 5x. Positive 9 take away 5 is a positive 4. Factors of 4 that add to 5, that's 4 and 1. X and 4, x and 1, and it has to be a negative 5. So negative 4 and negative 1 is a total of negative 5. Remember, this is still equal to 0. We did this in chapter 1. Okay? Let's keep moving. Make a t. X minus 4 is 0, x equals 4. X minus 1 is 0, x equals 1. There's my two answers, but I can't box them in until I check them. So let's go back up here and check. So I got a couple checks that need to take place. Let's try the 4 first. We try them one at a time. We don't try them together. So I put the 4 back in. Where's my original problem? So I have 4 minus the square root of 5 minus 4 equals 3. Now, I have to work on this side to see if it's going to equal 3. 4 minus 5 minus 4 is 1. The square root of 1 is 1. And 4 minus 1 is 3. That does equal 3. Check. We can circle this one. So it works. Well, you might say, well, that one's positive. It's going to work too. Let's check it to make sure. Go back to the original. I have to put a 1 in now wherever I see x. So 1 minus the square root of 5 minus 1 equals 3. 1 minus square root of 5 minus 1 is 4. And 1 minus 2 is negative 1. That does not equal 3. So it does not check. We would then reject. And our only answer is 4. So, to recap, process, whenever you see a square root with a variable in it and an equal sign, that's a radical equation or square root equation. Isolate. Get this thing by itself. I don't care what you move where, but get it on one side, all the other stuff on the other side. Doesn't matter if you move it right or left, it's got to be isolated. Once you have it isolated, you get to square both sides. Once you square both sides, you have to solve what is left for x. And then you have to check. Even if there's only one answer, you still have to check it, because maybe the only answer that you have still doesn't work. Okay? So, and that is chapter 3, day 5.